so we are starting our ballistics unit. So Harper can't handle it. Can you see her? Harper can't handle me talking with my hands. So we are going to show some football throws. Yeah, good. You know me well enough to know that I'm not a soccer player. Or I am a soccer player. I am not a football player. So I am not very good at throwing footballs. But I'm going to try to throw it a good throw, and then I'm going to, on purpose, maybe more on purpose than not, going to throw it a crappy way. Okay? Are you ready? That was pretty good. Okay, you got to give it back. You have to give it back. No, fine. Thank you. Relax. Good girl. Ready. Good job, Harper. Come on. Good girl. There we go. This was not cooperating this morning. All right, so ballistics. Ballistics, obviously, hopefully you know, has to do with the shooting and firing of a gun. There are lots and lots and lots of different types of guns, but there are a lot of similarities between some of them, and there are a lot of differences between some of them. So in your note packet, you should have blanks that will follow along with these slides. I'm going to kind of go through the slides kind of quickly, but I think you can always pause the video and go back. I can even upload the slide deck itself. This way, if you miss anything, you can just look up the slide deck itself. So it says explain the differences. This is the goal of the chapter. So explain the differences between a handgun and a rifle and a shotgun. Describe rifling on a gun barrel and how it affects the flight of a projectile. And explain barrel size and caliber. So if you were paying attention Friday afternoon and over the weekend, you might have seen, some posts about throwing a football. So the goal today is, as you watch this video, to think about why I asked you to throw footballs this weekend, other than just the fact that you probably need some fresh air. We're also going to hopefully describe how bullets are test fired and matched, discuss the role of ballistics recovery and examination at a crime scene, and determine the position of the shooter based on bullet trajectory. This last one's going to be a little bit tricky because it's math-based, and you know how I feel about math. And I probably won't ask you to do too terribly much in the way of that, only because I struggle with it myself, so I don't want to be sending you stuff that is too challenging to do without supports. So, the introduction here. Ballistic evidence helps explain what type of firearm was used, the caliber of the bullet, the number of bullets fired, where the shooter is located, whether a weapon was fired recently, and if a firearm was used in a previous crime, because you can match them up. A little bit of a history of firearms. So the Chinese invented gunpowder over 1,000 years ago. There were muzzle-loading matchlocks, which use wicks to ignite the gunpowder, which you can see over here. It's a little different than the guns we see today. In the 1500s, cartridges came out that held the bullets, primer, powder, and gunpowder, so that they didn't have to reload after every shot, which was a big deal. And cartridges were loaded at the breech, which is the back end of the weapon. Revolvers, semi-automatics, and automatic handguns. So, revolvers are one of the first handguns developed in 1835 that had a cylinder that could be loaded with several cartridges and fired much faster. So the cylinder turned as it fired. You might be able to picture some of those Old West movies with the little cylinder in there. The semi-automatic weapons, which fire one bullet per pull of the trigger, and then there are automatic weapons which fire repeatedly as long as the trigger is pressed. Long guns, there are a couple different types of long guns. There are rifles, which fire bullets, and there are shotguns, which either fire pellets, which will be basically in a canister, and they will kind of spray out when the gun is shot, or a single projectile, which you call a slug. And then there are handguns. Handguns are pistols that are fired with one hand. Revolvers, like we said, had a cylinder that hold usually 6 cartridges. Firearms and Rifling. So, this beautiful cartoon here is you looking down the barrel of a gun. The grooves and ridges, or lands as we call them, in the barrel of the gun produce a twisting that adds accuracy. This leaves a pattern on the bullet that is unique. So each inside of a gun is unique. So even like the same type of gun might be mass produced, there are going to be uniquenesses inside those lands and grooves that you're going to be able to determine from some forensic investigation, that you can narrow down which gun has shot which bullets, even if it's the same kind of gun. Cartridges is a case that holds the bullet powder, holds the bullet, the primer powder, and the gunpowder. So that's the whole thing is the cartridge. The bullet is usually made of metal. That's the top part, and it is the front part of the cartridge. And then the rest of it, the bullet case, is where the primer and the propellant powders are. And then the rim is where basically the gun hits the rim to ignite all of the powders inside. And that's what shoots the projectile out. Yep, so the firing pin is the part on the back here that's at the base of the cartridge, and it ignites the primer powder. It usually, if you've ever seen, you have to kind of pull the trigger back, sometimes with your thumb. You pull it back, and then it hammers the cylinder there, and it shoots out the gun. The primer powder sparks through the flash hole to the main propellant supply, and then it causes the projectile to fly out of the gun. The pressure of the explosion pushes the bullet from the casing into the barrel. The bullet follows the lands and grooves, which makes it spiral out of the barrel. Caliber of the cartridge. So the caliber is a measure of the diameter of the cartridge as well as the inside of the firearm. In hundredths of an inch, it's usually measured in. So common calibers are 22, 25s, 357, 38s, 44s, and 45s. Caliber of ammunition should match the firearm that it shoots, because otherwise, excuse me, otherwise the bullet will not fit correctly and it will not shoot. It may not shoot at all. If it does shoot, it will probably shoot poorly if it's not for the right gun. If a bullet is removed from a wound at a crime scene, its caliber can link it to the weapon used to fire it, at least the type of weapon. The marks left on the bullet are what's going to lead it to the exact weapon. So each fired bullet is marked with its own unique pattern of lands and grooves. To get a known bullet for comparison, investigators will test fire the weapon into a water tank or a gel block. This captured the bullet without damaging it, so they need something to compare it to. Just like when we had our fingerprints, we had that big packet of fingerprints to compare the ones that we were finding around the room. Same thing happens when you find a bullet at a crime scene. You need to have something to compare it to in order to see if it matches. Investigators can then compare the markings on the known bullet with those on the suspected bullet and try to make a match. There also will be marks on the spent cartridge casings, which the cartridge casings obviously don't shoot out with the bullet, but they kind of pop out of the side of the gun in most cases. There are some guns that hold the cartridges in it, and then there are some guns that the cartridge pops out of the side of the gun. So you can match up firing pin marks. They'll appear on the rim or the center of the spent cartridge. They can be used to match a cartridge to a firearm. There are also what's called breech block marks, which are produced when the cartridge casing slams backward and strikes the breech block, which is the back end of the gun. There's extractor marks, so there'll be like minute scratches produced on the cartridge that is in the firing chamber. And then ejector marks are also minute scratches produced as the cartridge is removed from the chamber. So as it kind of pops out the side when the gun is shot. This is only in the semi-automatic and fully automatic weapons. When the gun is shot, the cartridge pops out the side, and there will be some marks left on it from that would be unique to each gun as well. Gunshot residue, GSR we call it, is Particles of unburned powder and trace smoke that leaves traces on the hands, the arms, face, the hair, or clothing of the shooter or victim. Only if you're in close proximity, though. It's a long range shot, you're not going to get gunshot residue. Oh, excuse me. You're not going to get gunshot residue on you or on the other person. Chemical testing can detect the residue, even if removal is attempted. The distance from the victim to the shooter can be determined by examining the residue pattern on the victim, if there is one. If it was too far away, then there isn't one, and then you can't do that. So here's where we get into a little bit of math. So basically, if you have a bullet hole, you need what we call 2 reference points to define the trajectory. So in this case, in this picture, you have a car with a bullet hole in the back of the seat. So the investigators can figure the shooter discharged the firearm somewhere along that line. They're talking about this line right here, the C line, somewhere along that C line. So basically they're saying this means this is where the bullet hole was. This is a straight line to the horizon. Okay? And then they know that it probably came from above and it came down. So their job is to try to figure that out. The car, between the car and I believe that in the next slide it's going to show you that B represents the face of a building. So that's a fixed point that you can use to measure. The car is at a fixed point and the building is at a fixed point. So that's where they get that 60 feet from. So that's where that letter A is coming from, just so you know. So reference points can be bullet holes in the object or the victim, an entry point or an exit point on a victim, gunshot residue or spent cartridge casings, and then lasers can trace a line path to determine the rough position of the shooter. Could also use math to determine, the position of the shooter. So the building, like I said, is 60 feet away along the horizon line, and the bullet hole is 4 feet off the ground. Obviously, in this picture, we can't see the ground. But so you have that information. Then the question says, okay, where is the shooter located? Well, I don't know either. But here's what you have to do. So you're going to use a little bit of the, most of the Pythagorean theorem here is what we're going to use. But basically, here's a bullet hole. Again, the face of the building, the big A, big C, and big B, that's your big triangle. But your little triangle here would be proportionate to the big triangle. So it says B is where the shooter is located. We know. We don't know how high up that is, but we know that's B. Okay? Find the length of BC. So you're going to do some math to find the length of BC, which has been a little while since I've done that kind of math. But if you look at the big A, little BC triangle, it's the same proportions as the big A, big B, big C triangle. So again, this small triangle here is the same proportions as this big triangle here. So if A over B, these are fixed points that you can measure. Big A to little b, you can measure. Okay, and big A to little c, you can measure, which is what they were doing here. That's what these distances were here. So distance along the horizon to the window. From the bullet hole to the window is 23.5. From the bullet hole to the distance along this path was 23.9. So that's where they're getting big A to little b and big A to little c. That's this triangle here. So big A to little c, here's your numbers that you know. And then this one, 720 would be your 60 feet in inches is 720. So that's where that number is coming from, this 720, because it's all in inches. So this 720 is this from big A to big C, which we could measure because we had the face of the building there. So if these are all the case, based on the Pythagorean theorem and the fact that I believe you have to do some crisscross multiplying, you should find out that AB is equal to 732.3. So that would be this line here, big A, big B, 732.3. So then you can triangulate using the Pythagorean theorem, which kind of hurts my brain, but here's how that works. So you have your big A to big B squared is equal to big A, big C squared plus big B, big C squared. So you know a lot of this information. This one you don't know. B to C, I don't believe you know yet. But that's what we're trying to figure out is B to C. We already know A to B, and we already know A to C. So it's 32.3 squared, which is what we determined on the last slide, is what AB is squared. 700 equals 720 squared, which again is this one. That's 60 feet, we know. So that's where that A, big C squared number comes from. Plus BC squared, which is again what we're trying to figure out. How high up was this shooter? Were they on the 3rd floor? Were they on the 10th floor? That's what we're trying to figure out. So by doing some algebra, you swap it around and you get that BC squared is equal to 732.3 squared minus 720 squared. So here's those numbers here. You end up with B squared equals 17,717. So you have to take the square root of that to undo the square. And you find that BC is 133.1 inches. So 133.1 inches is from B to C. But don't forget that C is 4 feet off the ground. So 4 feet, 4 times 12, would be 48 more inches added on there. Okay, so BC is 11.1 feet, plus you have to add in another 4 feet. So your total should be, we know that the bullet hole in the seat is 4 feet above the ground, so the shooter must be 15.1 feet above the ground, which is why you're getting, I want to move the mouse down there to show you the 11.1, but every time I do, the little thing pops up. The 11.1 is what BC equals. And then again, you're adding in from C to the ground here is 4 feet, which is why you're adding in that 4 feet to make it 15.1 instead of 11.1. That's where that number is coming from. So then you have bullet wounds. Bullet wounds can have entrance wounds that are typically smaller than exit wounds because the skin is somewhat elastic. So it stretches when a bullet enters the body. Therefore, the size of the entry would be smaller than the bullet. The exit wound is generally larger because as the bullet moves through the body, it may collect and carry blood tissue and bone with it. If the bullet penetrates clothing, fibers can be embedded in the wound, pointing in the direction of penetration. In addition, the GSR is typically only found near the entrance wound. So this is all going to help people figure out which side of something. If the bullet went all the way through, how do you figure out which way it went in and which way it came out? If the gun is fired with the muzzle touching the victim's skin, the muzzle may leave burn marks because the muzzle will get really hot. Small caliber bullets such as a .22 tend to lodge within the body, while larger bullets will pass through. High-speed bullets are also more likely to pass through the body than low-velocity bullets. I think that is it. So you are going to hopefully have written down all those notes. Feel free to replay this video as much as you'd like. And then I would like you to go over to the Google form that is attached with this video and the notes. And please give me a description of why in the world did I have you playing with footballs this weekend. I hope you're all doing well. See you soon. Good job, Harps.